Arjumand and this is business maths and statistics, and we will be starting module number 5 today. And this module is especially for those people, for those students who are doing their maths MBA, masters in business, or masters in finance, or masters in banking, or for those people who are doing their bachelors in electrical engineering, or for those students who are doing their engineering. So this module is very easy and very basic. Let me try to explain you. In module number 5, we will just start with statical data, representation, and measures of central tendency. We know that we have, what is data? This is important thing. So data is anything, any information that is collected in a different form, we call it data. So any information we usually sometimes organize in ascending or descending orders, and for the collection of data we call it as statistics. And for collection of data we do have few methods also. Let me just try to explain you, start from the basic, because in this lecture they haven't explained you properly. Okay, so if I said, let me try to write it for you. We do have 3 types of series. We collect data in series. So just a minute, sorry. Okay, so we do have series, series. We collect data in series, and the first way of collecting data we call it individual. So I'm just writing indi, that will be easier for you. And the second method of collecting data in a series, we called it discrete data. Okay, so here I will write D, so it will be easy for you, discrete data. And the third thing that we will collect data in continuous series form. Okay, so I'm writing C for continuous form. Okay, in continuous form we still do have 2 methods. The first one we called it inclusive method, and the second one we called it exclusive ones. Okay, I know my writing is very bad now because I'm just trying to write on drawing board. Okay, so for series individual data, for example, we do have 100 students, so and all those 100 students receive different type of marks. So I will write like one by one for each and every one. We call it individual data. For discrete data, I will just arrange it in one form. For example, for those 10 students, the test was out of 10. So I will just write it down like this. I said, okay, from 0 how many students 0 get it, and how many students will get 1, or how many students will get 2, or something like that. And here I will write it down the frequency. We call that discrete data. The third thing, for inclusive data, we just write it down the classes, class intervals. And for exclusive also, that's class intervals is important. Okay, I'll further explain you that how this data will be handled. Okay, we do classify this data into 5 parts. The first, qualitative manner, and the second one is quantitative manner, the third one is geographical manner, and the fourth one is chronological or temporal manner, and the fifth one by the time of occurrence, which one comes first. Okay, this thing. Okay, types of classification. For individual data we do have only one way, for example the population, if I'm writing. But for discrete data, or for inclusive or exclusive data, we do have 2 ways or 3 ways. We will explain. Okay, methods of presentation. We do have different types of methods of presentation. The first one we call it text, like books in written format. Okay, the second one we do have data tabular forms, mean in the form of tables. So semi-tabulars means some of the tables form data in a rows. Tables with rows and columns you will see in this one. Okay, and then graphs, charts and graphs, pictures and graphs. These are the things that you usually see on Facebook also. They will give you some pictures like burgers or like flowers, and they will ask you, okay, so 2 flowers is equals to 20, so how many flowers will be 2.5 or 2.25, like these ones. So this is, we called it picture graph, or another name for picture graph is pictograph. Okay, then we have sector graph. Sector graph is equals to 360 degrees, and we divide, for example, we said that this is 31%. So when we have 31%, so what is the 31% of 360 degrees? We will just distribute it. Okay, so this one, column and bar graph, is very easy. They make a column and they make bar, but these bars in column and bar graph, the bars are separate. Remember this thing. Okay, so while they will ask you to draw a bar or draw a column, please don't try to attach each and everything together. Okay, the next graph, we do have a line graph. From grade 3 or grade 4 we have learned this type of a graph, although in further lectures we will learn about how to do the line fitting in these graphs also, while we were discussing regression and regression analysis also. Okay, this is time needed to be located in a library material. So this is a time graph, we call it. Normally, according to the law, the time should be on the x-axis, sorry. Okay, the next thing we do have in this lecture, that's again they have discussed about the line graph, and they have shown two graphs in two lines in one graph. So here the light one, if you can see guys, the light one and the dark one, female is having the dark line and the male data is having the light line. So they can provide you these types of two data where they will provide you two different lines, sometimes three different lines in single graph. Okay, this is another method. Can you see this thing? In the temperature in a different cities, temperature of cities in A and B. This one, morning it will be different and at night it will be different. So okay, what is central tendency? Central tendency is basically the middle value of something, or some typical data. So central means middle, tendency we use it as a word for values. So we do have different types of central tendencies. For example, mean, median and mode. You have learned these things from grade 5 or 6. Okay, what is mean? Mean is mostly commonly used measure of central tendency. Mean, we also call it average. Remember this thing, because while we were young we have learned this thing, that add all the numbers and divide by the numbers of the number. This formula we call it mean, but this is a simple mean, or we call it arithmetic mean. Although we have different types of means also, we will learn in this one. Especially after arithmetic mean, we will learn about geometric mean and harmonic mean. These two means are also very important, especially for masters. Okay, so they have given you one example also. They have given you a data of three numbers, and they will ask you, so once you add all these three numbers, you have to divide by 3. If they are 7 numbers, you have to divide by 7. If they are 10 number, you have to divide by 10 after adding those numbers. So mean is simple. Okay, then after that, median. What is median? Median is a middle value. Okay, remember this thing, for the formula of mean, arithmetic mean, for individual series the formula is different, for discrete series is different, for continuous series is different. The same thing applies to median and for mode also. The formulas are different. I will explain you each and everything one by one. Okay, for median is the middle value, or we also call it, we arrange the data in ascending order. So whenever the word median came, we should remember this thing, that median should be in ascending order. In some cases descending order is also fine, but it can change your results, or it can change your numbers, or the but better to write it down in ascending order. For example, if you are having even values, so you will get two numbers in the middle. So what you will do with those two numbers cannot be a median. So what you will do, you will add both the middle two numbers together and divide it by 2. But if you are having odd number values, it will be very easy. The middle one will be your median. One of my students, he used to use the method for median. Now he is in grade 11 IGCSE. He used to use the method of cut. So he cut one from here and one from here, then one from here, then one from here, and he said this is a cut method for median. Okay. Then we'll discuss about mode. What is mode? Mode is the most common number or most occurring number in a series. Okay, so here if we said, okay, which one is the most common number here, we'll say, okay, 1, another 1, 2 times 1, 3 times 1, 4 times, 5 times, 6 times, and 7 times 1. So we are having 1 is the most common occurring number. Sometimes we do have 2 modes or 3 modes. For example, we are having 2 7 times or 3 7 times. But if we are having 1 7 times and 2 6 times and 3 5 times, so which one will be the mode? 1 will be the mode. Why? Because 1 will be the most occurring number. Or sometimes we don't have any mode, not even a single one. So it's also possible that you won't have any mode, or you don't have any number that's occurring again and again. Okay, at your level they usually ask you the advantages and disadvantages of mean, median, and mode. So please remember this thing, that mean is quick and easy but not reliable, or may not represent the whole sample. For example, for mean, if I said give me a minute. Okay, so here instead of 4 8 and 9, I'll say 1 2 3 4 5. If I add these 5 numbers, the total will be 15 over 5. But if I add one more thing, 1 2 3 4 5 and 51, the total will be 66 divided by 6. So before that my mean was 3, and now after just adding one single number, my mean changes into from 3 to 11. So mean is not mean may not represent the whole sample. Okay, for median, median takes all number into account equally. So from right side and from left side, it equally accounts. Or more tedious to calculate than other than 2, can be affected by few very large or very small. Remember this thing, few. Okay, but in this one, in mean can easily affect by large number or small number very easily. Okay, for mode, we do have fairly easy to calculate. Half of the sample normally lies above of the median. So median, if it's the median is the middle, so it's above of the median, means more than median or more numbers that occurs, we call it mode. Okay, on disadvantage, tedious to find for a large sample which is not in order. So if the numbers are not in order, it will be very difficult for us to find mode. Okay, so for organizing data, we have few methods. Number one, we called it numerical data, and numerical data is a number form. Any data that is in a number form, not in a any one, like alphabetical numbers or word numbers. Okay, the first method we have order array, means you just arrange whole data in ascending orders or in descending orders. The second method, we have a stem and leaf display. Let me show you what is a stem and leaf display. So this is the data. This was the data they have given us. So here we have a stem. For example, how many 20s we have, we will just write it down. So we have 121. So this one is, we will write, this is a stem, this is the base, means this is the tens, and this is a unit. We have written it over in the place of leaf. Okay, next thing we have for organizing numerical data, we have frequency distribution, cumulative frequency, histograms, tables, polygons, or guide. Okay, one by one we'll just see each and everything. Okay, so for the summary, there are two different ways of organizing: univariate categorical data, and okay, this word univariate and bivariate you will learn. The word uni is means one and bi means two. When you have a single type of a data or one type of a data, we have learned it before, then you will organize your data in a summary table, or in a bar form, in a pie chart, or in a Pareto diagram. Okay, Pareto diagram is the diagram, I think so I have a picture over here for Pareto diagram. Pareto diagram is no, we don't have it, bars and lines together. Okay, that's we call it Pareto diagram. Okay, for bivariate categorical data, we do have contingency table. We have learned it in grade 7 and 8, and side by side bar charts, like we do have. This is different types of data while we got it together, so we called it this thing. Okay, tabulating numeral data, we do have group data into classes. Classes, what is the class? You have to know. class is a number of series. For example, in above example I have explained you, those 10 students receive different marks or 100 students receive different marks. So the marks, when I write it the marks, it will be class, and the frequency I will write it down. It will be the number of students who received 2 marks or 4 marks or 5 marks or 10 marks, like that. Okay. So number 1 for tabular data, or tabulating numerical data, we have to sort out the data in ascending order. That's the first thing. Okay. For range, we have learned the range. Range is maximum value minus minimum value. So in this one, which one is the biggest value? This one is the biggest value, 58. And which one is the smallest value? That is 12. Okay. So we subtract 58 minus 12 and we will get it 46. Okay. Then after that, we will select the classes and we will make the classes with this data. So for example, the first class I will make it, I'll start from 10 to 15, one class. So all these two number will go in one class. And the second one I will start it from 16 to 20. So this one will go in 16 to 20. The third data I will make it from 21 to 25. So 1, 2, 3. These three will go in another class. So like these types of things, we have to usually we make minimum 5 classes and maximum 15 classes in series data. Okay. Then after that, we have to compute the class. How? For example, if I get the answer 3.2 or 3.8 or 3.1 or 3.3, what we will do, we will always round up. We will never rounding it down or round off. We will always round up. Okay, in statistics. Okay. So for example, if we want to find out what is the class width, how we'll find out? We'll find out the range first. So, and then after finding out the range, the number of classes, we'll find it out, and then we will write down the answer. So here, and the range was 46, and we made 5 classes in these ones. So once we made the 5 classes with these ones, we'll divide 46 by 5. The answer we'll get it, it's 9.2. But for this one, we don't round off. We usually in mathematics, if the number is smaller than 0.5, we will round off. But here in statistics, we never round off. We always round up. So it will be 10 instead of 9. Okay. How you will determine class boundaries or limits? The class width times the number of the classes. So this is the width. Let me just show you. I'll explain you. Okay. So just a minute. So if I write these data in a tabular form or tabulating numerical data, if I am writing, so I will always multiply. So how I will multiply? Times by the number of the classes. So class width, if the class width is 5 or 10, I will multiply that 10 into 5. Okay. So they have given you one example also. So 10 plus 10, 20. What is 20? 20 is equals to 10 plus 10. And what is 30? 30 is equals to 20 plus 10. So we'll always add up the 10, that one, because the class width was 10. I distribute, instead of making 5 numbers, I took just from 10 to 20, that is one class, and from 20 to 30 another class, from 30 to 40 another class, and from 40 to 50 another class. So the class width will be 10, and the number of classes, how many classes I made it? That's I made it 5 classes. So the total number of values will be 50. Okay. And once I'll get the 50, I'll just show this thing like this. This is how to make class. Okay. While you're computing class midpoint, what is the midpoint? So you will take the lower limit and the upper limit, and you'll add up both of them and divide by 2. How? So for example, here you can see they have done the same thing. Let me show you. So for example, if I have a data over here, that is in which one the first number is 10, the second one is 20, the third one is 30, the fourth one is 40. So what I will do, I'll take this 10, the first place it will be 10. Okay, the second place, what I will do, I'll write 10 plus 19. Okay, why? Because it's inclusive, not exclusive. Okay, if it's in exclusive, then it will be done differently. In exclusive, what we will do, we'll say, okay, till 20 it will be there, the next one will be starting from 21 till here, so that is exclusive. But this one is inclusive, so the next one what we will do, we will write 10 again, then plus 1 less than 30, it will be 29. Okay, then the third one will be 10 plus 1 less than 40, it will be 39. Okay, back to our handouts. So here we'll get something, and after adding each and every number, you will get it to the numbers in your decimals. So once you get the numbers in decimal, what you have to do, you have to round up. Don't forget to round up. Okay, so the class intervals should be, they have explained the same thing, 10 plus 19, 10 to 19, the class interval will be here, or 10 but under 20. Can you see? Similarly, other 4 classes intervals are from 20 to 29, then they have started from 30 to 39. Why? Because this is inclusive, not exclusive. If it's exclusive, what it will be? It will be 20 to 30 and from 30 to 40. So from 20 to 30 means less than 30, means it will stop at 29.8 or 29.9. But from 30 it will come from here, and from 30 to 30.1 up to 49.9. okay, so up to 39.9, so it will be like that. Okay, then we have frequency. Frequency is the number of occurrence of something, or how many times, or what is the interval that something is coming. So for example, students receive from 10 to 19 number, how many students were there, that is frequency. So 3 students receive numbers from 10 to 19, or 6 students receive numbers from 20 to 29, and 5 receive 30 to 39. This is the frequency, we called it. Okay, so what we will do, we will write it down the frequency, all of them together, to find it out the relative frequency. Okay, how we will find out the relative frequency? Relative frequency is frequency of class interval divided by total frequency. So for example, if I want to find out the frequency of this class, this one, so what I will do, I will write it down 6 divided by 20. So once I will divide 6 by 20, I'll get answer. Okay, so or if I want to find out the frequency of this class, the first class, so how I will write it, 3 over 20, and that's how we will write it down, the relative frequency. Once you get the relative frequency, don't forget to change it into percentage. So once you will change it into percentage, you will get the relative frequency will always be obtained in percentage. Okay, so that's a tabulating form. Tabulating numerical data, frequency distribution. This is the class they have written. So 10 but under 20, 20, this is exclusive data. Okay, they have explained you over here. So this is the frequency they have given you, and the relative frequency and the percentage of relative frequency, you can just go and check over from here. Okay, for cumulative frequency, what is the word cumulative mean? Cumulative means that you have to add this one and this one together, or this one and this one together. So the first one will stay the same in cumulative frequency, so it will be 0.15. But for this one, what you will do, you will just add 3 plus 6. Okay, and for the third one, you will just add 3 plus 6 plus 5, and the fourth one will add just 3 plus 6 plus 5 plus 4, and for fifth one you will add 3 plus 6 plus 5 plus 4 plus 2. The total number of cumulative frequency is always be the number of frequency. Okay, we can have an example over here. Okay, so the first one we have a 15. Can you see this thing? This was a 15. So for cumulative frequency, the second one, 15 plus 30, it will be 45, and then 45 plus 25, and then 20, then 10, and it will be the total number will be the 100. Okay, this one will be the cumulative frequency. It's easy, it's not that difficult. You just have to find out that how to do it. Once if the concepts are clear, it will be very easy method, and it's very easy topic also. Okay, how to graph the numerical data or histogram. This is the example of histogram, or histogram is an example of frequency distribution. If somebody asks you how to distribute a frequency, this is the the method. You can write, or you can show, or you can explain them. Histogram is basically the bar graph of frequency distribution in width of the bars to the proportion of the classes into which the variable has been divided. So now here the main thing comes. Okay, here they have explained you the arithmetic mean, and again, for arithmetic mean we do have different types. For individual arithmetic mean we have different formula. For discrete arithmetic mean we do have different. For group data, for continuous data, we also called it continuous data, we do have a different type of arithmetic mean. Then we have geometric mean, harmonic mean, weighted mean, and truncated mean or trimmed mean, winsorized mean, and median and mode. Okay, let me just try to cover this thing as much as possible, but if I couldn't, then I'll just continue in my next video. Okay, one more thing, that these formulas you should know how to use in Excel. In Excel it will be very easy, it's not that difficult, because average is mean. Average A means arithmetic mean, once you know, and you know, don't forget to write it down, the equal sign, before writing any formula, so it will be easier for you. Okay, so for while you're writing average A, it means that you are trying to find out arithmetic mean. They will ask you in exams that how will you find out that arithmetic mean on Excel. So average A, bracket, and the values then you want to find out. You can just take a reference from one side and another side and put a comma in between, and it will be done. Okay, like this one. Okay, so average of the numbers above and the text not available. If the text is not available for average, it won't work. But for average A, if the text is available, if it's true, it will consider as correct number. If it's written false, it won't take that number at all. Okay, for median, it's easy. Again, you just have to put the name syntax median in Excel. You'll get the whole formula. You don't have to memorize or cram the formula at all. Write down is equals to median, take one reference, the whole bar, take it, copy, put an equal sign, put another, take another bar, another reference. It will be easier for you to find out the mode also. Okay, for median also. Okay, for mode it's same, nothing is different. You just have to find out the equal sign and mode, and for a little bit mode it's a little bit different. For example, if it's true, that I have explained you before also, it will count it as a number. True is 1, and for false it's 0. Okay, so for frequency, yeah, it's a little bit different. For frequency, what you have to do for frequency, it's a data array bin array. So for while you're try to find out the frequency, the formula is a little bit different in Excel. So it's here, can you see? So I do have this thing. So control shift enter and then formula. After writing the formula, don't forget to press control shift and enter. So press F2, then press this thing. Okay, after writing your formula. Okay, sum fx, sum means the total of frequency, and x is this class marks. Okay, so while we are doing this thing, arithmetic mean of a group data, so arithmetic means to find out, okay, we called it this thing as x bar. X bar means the total number of x, that how many the people are there. This is the frequency, that how many people are there and how many marks they will get it. So once we multiply frequency time x is 22, so 4 times 27 is 108. We multiply these things to find out x bar. Once we'll get x bar, it will be easy for us to find out the mean. Okay, so for calculating arithmetic mean on Excel, don't forget to multiply this thing first by using the sum formula, sum bracket fx. So once you will write sum form is equals to sum bracket fx, you will get this thing at the end. Okay, okay, the next thing, equal sign and round, and then choose references from the bar. Okay, okay, this, wow, we have completed the whole lesson. Okay, This one, frequency again. How to find out the fx. Okay, why we need this fx? We need this fx to find out the central of measures of central tendency, or we'll find out the dispersion of data. For dispersion of data, fx is important. Okay, that but if you can't find the fx, it will be very difficult for you to find out dispersion of data. Okay, now you have frequency. Frequency is equals to data, array, bin, and array. Okay, equals, the formula is same, equals frequency, then you have to choose one bar, and like this one I'm choosing from here, from A3 till A19, then comma, then I'll select these three and I'll write it down. Okay, after this one, don't forget to press Control, Shift and Enter. These are important, especially for frequency. Okay, and they have shown the same thing, relative frequency and cumulative frequency in Excel. Okay, graphing numerical data, the frequency polygon. Okay, how you will make it, or what is the purpose of making this thing? The purpose to find out the midpoint or mid hinge for this thing. Okay, while you find out the midpoint of frequency polygon, it will be easier for you to assemble your data. Okay, what is cumulative frequency? I have explained you already. When you once you add last frequencies or last percentage of frequency together, you'll get it. Okay, one more thing. Another name for cumulative frequency is polygon ogive or ogive. People just pronounce it differently. Okay. Then after that we have graphing numerical data, and how you will graph it. We do have, this is the ogive process, class boundaries. Okay, not midpoint at all. You cannot see any midpoint. Can you see? Just let me just try to show you in a bigger version. There is no midpoint in this one. So this thing we called it cumulative polygon. And then after that we do have tabulating and graphing categorical data, univariate. You do remember, in which we have only one variance or one variable. So while we have in one variance, we do have, how we will write, we will write down the data into two categories. The first one is tabulating and the second one is the graphing. Okay, for graph, pie chart, bar charts and Pareto diagrams, these all three come in graphing data. And tabulating, these tables, these types of tables, we call it tabulating data or the summary tables. Okay, so oh yeah, it's here, Pareto diagram. I was explaining you about the Pareto diagram. In Pareto diagram we do have bars as well as the lines together, okay, to explain the midpoint. Okay, this is the contingency table that we have learned in grades 3, 4, no, not 3, 4, 5, 6. Okay, so this is the contingency table, side by side charts. This is the one we use it for, especially in stock markets. While I was explaining you guys the stock exchange, this data, this type of bar, I have used it a lot. Okay, then what is the geometric mean? Geometric means that whatever the data you have it together, you just have to multiply all of them together. Multiply and then divide by the exponent. Oh, okay. Multiply everything and then bracket close, and the exponent should be 1 over n. Okay. So that's an example. If I have find GM of 130, geometric mean. GM means geometric mean of 130, 140 and 160. So what I will do, I'll multiply 130 by 140 and again by 160. And how many numbers are there? 1, 2, 3. So this n explains you the numbers. Okay. So I will just write an exponent 1 over n in a scientific calculator, and you will get your answer. Okay. 1 over n, or 1 over the numbers of the numbers. Okay. Harmonic mean, what is the harmonic mean? Harmonic means defines as numbers. For example, if I use the same example, I have 1, 2, 3 numbers. Okay, 3 numbers. Then what I will do, I'll just write it down, 1 over 130 plus 1 over 140 plus 1 over 160. So once I will write these 3 numbers, all of them together, I'll just get 3 divided by 1 over 130 plus 1 over 140 plus 1 over 160. Or here they have given you one more example. These are three number 10, 8 and 6. For 10, 8 and 6 it's very easy. So they have just have to divide it and write it down your answer. Okay, for quartiles, deciles and percentiles, the formula is same. N plus 1 divided by, for quartiles you have to divide by 4, and for deciles you have to divide by 10, for percentile you have to divide by 100. What changes? So for first quartile, the number we have to multiply by 1. Okay, the whole equation we have to multiply by 1. For second quartile we have to multiply by 2. For third quartile we have to multiply by 3, and this is how it goes on. Okay, for discrete data the formula will be little bit different. This is for individual data. Okay, individual series. For discrete data the formula is qi, it's ith quartile is equals to L is lower boundary, plus H is the width of the class, F is the frequency or cumulative frequency, that's why we have to find it out the cumulative frequency, CF in each and every frequency question. Then sum of F or sigma F, or not sigma F, the sum of F or when sum of frequency divided by, for quartile you have 4 times by I minus CF. Okay, so they have given you one example also, this one. So I is equals to 1 comma 2 comma 9. So this is the data they have given you. So for this thing it will be very easy. They have just put in the example and it's easy, it's not that difficult, although they usually don't give in exams group data because the time is very limited. But the basic concept you should know, that they can ask you, is this the formula same or not same, or correct or not correct. For multiple choice question they will ask you the formula. Okay, for percentile formula is again same. Can you see p and p1 is equals to n plus 1. Okay, why we plus 1? Either it's the number is odd or even, we always plus 1. For quartile we divide by 4, for decile we divide by 10, for percentile we divide by 100.
here, and after 5 I have 6 and 7. So, okay, so this was our median. Okay, so how far, or what is the difference between these ones? We call it dispersion. If the dispersion is less, or what is the difference between here, what is the class intervals and everything? We call it dispersion. If the dispersion is less, we call it, okay, this data is good. If the dispersion is more, we say this data is weak. Okay, sometimes we have, for example, we have 2, 2, 2, 2, 2. So, okay, the median will be 2, we know it. The middle value will be 2, the central tendency will be 2. We know it. Okay, what is the difference between these ones? What will be the dispersion? In this case, the dispersion will be 0. Okay, another case. I have 1, 2, 3, then 4, and then 490. Okay. So we do have mean. Mean will be 500. Okay. Mean will be 500 over 5. That will be 100. Okay. The median will be 3. Okay. And there is no more than that one. So if I try to find out the relationship or the distance between from 3 to 490, here we call it a huge dispersion. Okay, a big dispersion. So this is weak dispersion, this is a strong dispersion, and this is no dispersion. Okay, I hope you will get this thing. Okay,